Well, howdy there, Internet students. Mr. Hermanson again. Today we're going to start Chapter 3. The first thing we're going to do is a number concept review. So there's going to be a lot of definitions here and just understanding things like the difference between factors and multiples, the difference between prime numbers and composite numbers, things like that. So you'll just have to pay attention, do some work on it. Okay. First problem says that 1, 3, 7, and 21 are factors of 21 because they are numbers that when multiplied produce 21. Yeah. Or I like to say 21 is divisible by those numbers. Now when we say divisible, we mean whole number divisible. So 21 is divisible by 1, 3, 7, and 21. Because when you divide 21 by those numbers, you get a whole number. Okay? So go ahead and see if you can list all the factors of 12. Check back, see if you got it. One thing I'll say is that factors almost always come in pairs. So if you list 1, you think of what number times 1 equals 12. If you think 2, then you think what number times 2 is 12. If you say 3, then you say what number times 3 is 12. And so factors are usually in pairs, unless it's a perfect square number. We'll probably get to that. So we want to figure out, is 8 a factor of 28? Let's do it this way. If you do 28 divided by 8, it should come out to a whole number if it's a factor. In other words, 28 is divisible by 8. And we get 3.5, so we're going to say, no, not a factor. And we will say 28 is not divisible by 8. Sorry about the writing. Okay. Darren says that since 7 is a prime number, it has no factors. Is he correct? Well, here's what I think. You have to. Is there any number pair multiplied together that equals 7 where they're both whole numbers? The answer is yes. There is. 1 times 7 equals 7, which means 1 and 7 are both factors of 7. So prime numbers do have factors. They just have a limited number of factors. They have exactly 2 factors. They don't have any more than that. That's what makes them prime. So, no, he's not correct. It says list the first 4 factors of 20. Go ahead and try and do that. I'll check back with you. You should have got 1, 2, 4, and 5. Okay, now multiples are a little bit different. A multiple is if you take any number like, let's say 10, and multiply 10 by anything, 10 times anything that's whole, any whole number, you will get a multiple of 10. So like 10 times 2, 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 100 is 10,000, 10 times 90 is 900. So these are all multiples. Okay, check out this for a little bit more about that. So go ahead and list some multiples of 6. You should have gotten numbers like that, and the list of multiples, as you can see, will go on and on forever and ever. There's no end to that, where every number has a certain number of factors. Okay. So it says list 4 multiples of 20. Go ahead and try that. Here's some that I thought of. Is 8 a multiple of 4 or a multiple of 40? Go ahead and pick one of those. You should have said 8 is a multiple of 4. 4 times 2 equals 8. Okay. So now that you know what those are, go ahead and do 8a, list 3 factors of 18 and list 3 multiples of 18. Okay, for the factors, I listed them all. You should have 3 of those. And for the multiples, I just did a few of ones I could think of off the top of my head. Which list is finite? That means you can count the number and it has an end. The factors are multiple. So this set, are we done once we list all those? Or this set, we're done when we list all of them. So which is finite? Finite means you can count them. There is an end. Yes, factors are countable. There's only a certain number of them. Multiples are infinite because all you have to do to get another multiple is think of a different number to multiply the original number by. All right. So let's talk about prime numbers now. A prime number is any number that has only 2 factors, one in itself. Be careful about that. One thing, you could say 1, some people might say 1 is a prime because 1 and itself are both factors, but since they're the same number, we don't consider that to be a different number. So we may say that a prime number is a number that has exactly 2 factors, and since 1 only has 1 factor, it's not prime. Okay. So the smallest prime number is 2, and just to show you the factors, that there's exactly 2 factors, there they are, 1 and 2. Are all odd numbers prime? Well, let's think about the odd number 15. There's the factor of 1 and 15, but there's also a 3 and a 5 in there. So no, it has 4 factors, so 15. So the answer is no. Odd number, just because it's odd doesn't mean it's prime. Is 27 a prime number? I'm going to let you think about that. So think, is there any other numbers other than 1 and 27 that go into 27? So I'll write those down. So think, is there any other numbers that are factors of 27 other than 1? I said no because 3 times 9 is also 27. Is 67 a prime number? All right, check it out. See if you can think of any number other than 1 and 67 that 67 is divisible by. I couldn't find any, so yeah, 67 is prime. Okay. So a composite number is a number with 3 or more factors, so more than 2 factors. A factor tree can be used to create the prime factor list of a composite number. What is the smallest composite number? I'm believing that is 4, because 4 has 1 as a factor, 2 as a factor, and 4. So it has 3, or is the first number that has 3 or more factors. Okay. What are the next 3 composite numbers after 20? Well, every even number after 2 is divisible by 2, so every even number after 2 is a composite number. So after 20, so we have to think 21, is that composite? And we're going to say yes, because we also have 3 times 7, that equals 21. Okay, 22 will be composite because it's even, so that means there's something times 2 that equals 22, which is 11. 23 is prime because there's no other numbers other than 1 times 23 that'll give you 23. And 24 is composite because you could do like 3 times 8 to get 24, 4 times 6, 2 times 12. There's all kinds of ways. So those are the next 3 composites. Is 51 a composite number? Man, I know the answer to this, but I'd like you to just think, see if you could think of a number that might go in. And since it's not an even number, don't try any even numbers. So just try some odd numbers. The first odd number I would try is 3, and then, 5, 7, those kinds of things. So see if you think it's a composite number. Yeah, 51 is divisible by 3. It equals 17. So there's something else other than 1 times 51 that gives you 51, so it's composite. How about 53? Try that. I couldn't find one for that. So 1 times 53 is the only way I could figure out how to get 53. I tried dividing it by 3. I tried dividing it by 7. I'm not going to divide it by 5 because it's not a multiple of 5. So that's pretty easy to tell because it doesn't end in 0 or 5. But it's not divisible by 9. It's not divisible by 11. So I'm pretty sure that's composite. Are all composite numbers even? So see if you can think of a number that would be a counterexample to this. So an odd number that is composite. So I found the first odd composite number, which is 9, because 9, you can do 1 times 9 to get 9, but you could also do 3 times 3. So it has 3 factors, which makes it composite. Are all even numbers composite? They are, except for 1. Which even number is not composite? And you guys probably figured out that's 2. So the first even, but every other even number is divisible by 2, so it has to have at least 3 factors. So I'm going to say, I'm going to have to say no because of the number 2, but other than 2, yes, they all are composite. All right. So let's talk about what relatively prime means. Numbers are considered relatively prime if the only factor they have in common is 1. Okay, so in other words, there's no number you can divide both numbers by other than 1. So like the factors of 9 are 1, 3, and 9. The factors of 17 are 1 and 17. The biggest factor they have in common is 1, and that makes them relatively prime. So the greatest common factor is 1. Okay, let's try another set. The factors of 15 are 1, 3, 5, and 15. The factors of 18 are 1, 2, 3, 4 does not go in 18, does it? 3 times 6, 2 times 9, and 1 times 18. Now, it seems like this number 3 is in common, so it's not relatively prime, and the greatest common factor is 3. All right, why don't you try the next two? Here's my work on that. Okay, so factor trees. Prime factorization is a product, which means answer to a multiplication problem, of the prime number factors of a number. Generally, exponents are used when the prime number is listed more than once in the prime factor list. Find the prime factorization of each. Okay, I'm going to help you with this. So what you want to do is think of some numbers multiplied together that equal 18 other than 1. So like 2 and 9 would be good. And then if the number is prime, then you're done. Like 2 is prime. The only factors are 1 and 2, so that one's done. So a lot of people even like to circle them when they're done. 9, though, is not prime. We can divide 9 by 3. 3 times 3 is 9. But now both of these are prime, so we're done. So the prime factorization, one way you could write it is 2 times 3 times 3. But if you're lazy, you can use exponents when you have more than one of the same factor. So you'll probably see it like this more often. 3 to the second power. Okay, I'll get you started on this and I'm going to let you finish it. One thing I know is that when a number has ends in 0 that you can divide it by 10. So I'm going to do 54 and 10. Now neither of those are prime, so you're going to have to continue there. Give it a shot. All right, so I circled those so that you could see all the prime factors, and now I'm going to count. There's 2 2s, so I'm going to write 2 to the second. There's 3 factors of 3, so I'm going to do 3 to the third, and there's 1 factor of 5. So it would look like that. All right. Greatest common factor and least common multiple. What is the greatest common factor and least common multiple of the following numbers? All right, so to find that, the greatest common factor, we need to list all the factors. Okay, so for 30, I'm going to list, I'll just put it over here, 30, I'm going to list 1, 2, 3, 5, 6, 10, and 30. Those are all the factors of 30. For 50, I'm going to do 1, 2, 5, 10, 25, and 50. And I'm going to look for the number in the list that's the highest that they both have in common. That would be this one and this one. Okay, so the greatest common factor is 10. Now the least common multiple, the way I'm going to do that is I'm going to list multiples starting with 30 for each of them. And then I'm going to just keep going till I find one that they both have in common. 120 would be the next one. 150. I'm going to stop here because I'm thinking that one for sure will work. But so we got 50, then 100, and you can just keep adding 50 to get these. Yep. So the first multiple that they both have in common, that's called the lowest common multiple, is 150. Okay, so why don't you try that? See if you get them right. So I'm getting that the greatest common factor is 8, and the lowest common multiple is 120. All right. Okay, so if we want to know if they're relatively prime, another way to look at that, other than looking at all the factors, is to find their factor trees. And if there are no numbers in common, they're relatively prime. So 8, we would start by doing 2 times 4, and then the 4 we could break up into 2 times 2. And so we have 2 times 2 times 2, 2 to the third. 9, the only thing I can think of there other than 1 is 3, 3 times 3. Now both those are primes, so I'm going to write it as 3 to the second. Now notice we only have 2's to make 8, we only have 3's to make 9, so they're going to be relatively prime. Go ahead and try that method to see if 15 and 18 are relatively prime. Notice how they have a factor of 3 in common, which means they are not relatively prime. All right, so that should do it. You can go ahead and work on that homework. Use these notes to help you, and we'll talk about it next meeting. See you soon.